to summarize, let's sort of like summarize again. What is a pointer? A pointer is a variable, right? And it has to be initialized to be used. It has to be initialized with some useful, location in memory. And one of the possibilities here is to ask the variable itself for its address to initialize a pointer, right? Or later on I can point to some other place. Basically, I could have an integer, val2, and some other value stored in there, and I can essentially say, oh, and now location, grab the address of the second variable. Okay, just that's okay. You can change it. It's a true variable, so it can change its value, right? Other things are also available on the pointer. So then let me. So we said pointer is a variable, okay, and it stores addresses of other objects. But what is also given to the pointer is that every pointer points to a specific data type. Okay, so we were dealing with this example where it was a pointer to a character. In this example, this is a pointer designed to store addresses of integers and nothing else. If you want something else, you need to create another pointer. How this really can be made useful? Okay, so we can say that we can have a function, void function print, which actually is expecting a pointer to an integer. I'll name it pointer, PTR, in this particular example. And what it's going to do is it's going to do this, just similar to what we did here. Just simply say, hey, pointer, display that number. We know we're going to be getting an address of an integer, and our task is to actually print it. So that's all it does. In that case, let me declare this, right? So if I declare this function, I will kind of use a bit of an unconventional. So this is to keep everything in view, I will say this is a function declaration, right? So I declare this function, instantly inside my other function, right? And so then I can call it. So I can now say print. Typically, to not to confuse people too much, you would declare it somewhere here, right? So you just say declare it here. But it's possible to declare a function anywhere you want, even in the local scope of another function. So perhaps let me keep it right here. Oh, and the way I should probably reset this. Okay, so now print, and so this time print is expecting a pointer. But what is pointer? Pointer is a variable initialized with some address. So obviously I can say address of val, right? Or I can say an address of val2, right? Typically you don't use spaces in front of it. I don't know. That's my style, right? Or those are the possibilities. So far I have two integers. So this is quite useful. Right? This was kind of like really impractical, create two integers, then artificially create a pointer, ask an integer for an address, then use this weird notation to basically submit a copy of this value to an output and print it. This is completely, inflated example. But this example is very practical. There is a function that expects an integer as a parameter, address of an integer as a parameter. And so it can indirectly print, indirectly access that integer. It has no idea what that integer is, what the name of it is, but the caller knows. The caller says, I want to print val or val2. And in my case, I really don't want to make copies of these two variables. I just will give you an address, and you should be able to figure out how to access that object in memory and print it. So as you can see from this example, by the way, any questions about this so far? This, I'm just trying to make it really practical. Like, make a function that takes a pointer to an integer and does some work with it. Now, then you may say, well, this starts looking really silly. Okay, pointer is a variable which is being initialized by the caller here. Okay, and then, but we must tell the compiler that we want you, the compiler, to go to this memory and make 0 steps from there and extract an integer, and then obviously give it to cout to print. Okay, so what I'm saying is that this really looks silly. It's like, okay, I mean, come on, this just looks a little silly. So perhaps the alternative would be that most programmers would say just use a dereference operator. Those two lines are exactly the same. Dereference operator is recycling the asterisk, right? In general, there are 3 ways you can use the asterisk in C++ syntax. Multiplication, right? So we can say three uses of an asterisk in C++. There may be more. I just kind of think about 3 possibilities. One is multiplication, A times B, right? We know that's multiplication. And this is context specific, so in some contexts when you have 2 integers A and B, trying to multiply them, compiler will understand that this has nothing to do with pointers. This is multiplication, right? The second possibility is a pointer declaration, such as, you know, int, or we could use like a double, for instance, double pointer to dptr, whatever that is, okay? So the second use of asterisk is multiplication. Is the declaration of a pointer. In fact, in this declaration, the asterisk is pronounced as a pointer. So this little asterisk really modifies the type of the variable from being a double to become a pointer to a double. And when you try to vocalize it, you locate the name and say dptr is a pointer to a double. And obviously pointer to a double in memory. That's implied, right? So the third use of an asterisk, it's being just recycled. Instead of using different punctuation characters or combinations of such, just an asterisk is being recycled. The third situation is that where I say asterisk dptr, it's called dereferencing pointer. It means exactly this. Go to the location in memory specified by dptr, right? So I have to really sort of like probably initialize it with something at some point, right, to make it legal. Otherwise, we know it's going to crash, right? If you try to access memory, which is some sort of a junk, or does not belong to us, we're going to crash, right? It's just going to be memory access violation or really unpredictable results. But if you say asterisk, it's exactly as doing this, right? So again, this syntax already existed in BCPL prior to C. And then later on in C, Dennis Richard apparently decided to kind of say, well, this may not be the best way to represent indirection. Let's just use this more terse kind of thing, pointer dereference operator, right? So this is pointer dereference operator. This is what's called a subscript operator or index, right? Both do exactly the same thing. Let's continue this series of examples, and you can also Well, you say, okay, am I losing anything by switching to this notation? In reality, not. Remember, it's all like address expression, so my dptr plus 0 is the same as dptr. So under the hood, remember, this is just a variable that stores an address. So I can add like 10 to it and move 10 doubles up someplace and dereference that. So that's exactly as saying dptr10. That's exactly the same. So again, in this case, this notation wins because it says, listen, perhaps this is more, more intuitive to say we have an array of doubles, we have some address, and we want to move 10 doubles down and extract a number from there, a floating point number. Whereas right here we say we have a location, some address in memory. Let's modify that location to say plus 10 and then dereference it. Well, similarly, you can perhaps do the same thing by simply saying dptr equals dptr. Remember, it's just a variable, plus 10, right? And then you can say dereference dptr. So all of these do the same thing. So these are notations that are using subscript operator, and these are the notations that are using dereference operator. So there you go, your three uses of an asterisk: multiplication, context specific. If part of declaration, this is a modifier to the data type, which makes this to be a pointer, a variable specific to storing addresses, and this is pointer dereference. Yes, question?
So when you said